Cool. Now we're recording. Back to where we were. You want to give a new IP address, you go into the properties here, double click on this here, version 4, IPv4, you type in a new thing here. This field will automatically fill into 255.255, etc. You just got to put the right address in here. 192.168.137.1, and then you can connect to the same number, but .2, click OK, maybe validate your settings, you're done. You can always check to see if it worked by going back here. Anyway, hopefully all of your udoo boards are still working and connecting to your computers. If they are, maybe just leave it plugged in until August. The udoo pinout. This is how it talks to the rest of the world. This is the main brain, the processor of the udoo board. And it has two pieces, the A9 and the M4. The M4 has one purpose, and that is to run Arduino sketches. And we're not going to use it at all. None. The first thing we're going to do today is disable the M4 portion of the processor. And then after that, all of these pins, well, the analog pins and these digital ones, will go back to the main processor that we're actually using. If you haven't used Arduino before, these are the standard pins. You got 13 digital pins, 14 digital pins on this side. These two can be used for a UART, also called a serial communication. We got these two pins up here for I2C communication, and we can also use, I believe, A5 and A4 for I2C if you're not using all of those analog pins. This is the analog read. There's no analog write. You can read a voltage, you can't make a voltage unless that voltage is 0. And then we've got some power here for your other projects if you need 5 volts for something, 3.3 volts for something. Very important distinction here. These are all 3.3 volt pins. Usually for the Arduino, it's 5 volts. On this board, it's 3.3. So don't connect anything at 5 volts to this board. You can damage the board. I think that's what happened with Johan's board, is that last year someone damaged it and then just didn't say anything. But we'll never know. This is the outer row. And this one always belongs to the main processor. The A9. And these are the pin numbers, but these are the actual names, how you will address it in your programs. So maybe you use this pin number for something else, but in your programs, always use these names. Pretty straightforward stuff. Today, we're going to be all up in the udoo board using some bash to navigate the operating system and see what's there waiting for us. And also, we're going to do a lot of Python today. If you've never used bash, I guess you should have used it a little bit by now to check the date, to ping things, whatever. Here's how we're going to get around. ls, this just lists all of the files in the folder that you're in. cd is change directory. So you type ls, it shows you that there's 2 files in one folder. You want to look in that folder? First thing you got to do is change the directory. You give it the name of that folder, in it goes. If you want to go up one folder, you call that a dot. If you screw up and you get lost and you don't know where you are and you just want to go home, You change directory to home/home/udoo, and that brings you right to the beginning where you first logged in. Nano, this is a file editing program. If you're on the census team, you should have used this already for a simple project. If you haven't, today's your chance. MD is to make a new directory or a new folder. You just give it a name. I haven't tried giving duplicate names. We'll see what happens. MV, this is to move something from one folder to another, but you can also use it to rename. If you have a file and the name is name1 and you want to make it into name7, you actually just move the file to the same folder with the new name, and the old one is gone. RM, this is to remove something or delete something. Try not to delete anything that you didn't create. I really don't know what happens if you delete some files from the operating system. Cat. Everyone knows what a cat is, I hope. This is something else entirely. I don't really know why they call it a cat. But when you cat with a file, it reads the whole file and prints it to the terminal. If you want to read a file but put what you've read into something else, you use this little arrow here. Instead of reading it out into the terminal, it will read it into the new file. This is a quick way to make copies of something. And then echo. Everyone knows what an echo is? An echo is like when you shout something into an empty room and then the room shouts the same thing back. So normally when you just type echo and you say something, some text, the same thing comes up to the terminal. In this case, that's not really super useful, but you can also use it to write into a file. Why will this be useful? Let me show you. We already talked about the difference of an A9 and an M4. A9, this is just our main processor where we do all of our Linux-based computing. All of our Python programs are going to run on this processor. M4, the Arduino, we don't use it for anything. Maybe after August, you have so much fun with udoo, you want to try it using Arduino as well, you can. You have to get your own udoo board. I think the cheapest one is $50. There's a lot of good information on how to make this work on the udoo website. Cool. Okay, yesterday I told you a lie. I said there was one ADC and it had 6 inputs and there was a mux. Everyone remembers this? The truth is, there's 2 of them. This is what I showed you yesterday. What the hell? Don't do that. This is an engineering solution. Discipline. Discipline matters. Yesterday I told you we had like this. 1, 2, 3, 4, 5, 6. Weird. 2 control lines and 1 output, and that this was the ADC on the udoo. This is not the case. Let me show you the real case, the true case. Oh, this should have been 3. Huh. Huh. Then this will be device 0, and this will be device 1. So yesterday I told you we're 0, 2, 3, 4, 5. Now what we really have is 0, 1, 2, 3, and then 4 and 5 are here. Why does this matter? Well, maybe you need to read two things at the exact same time. You can do that if you set it up properly. If you don't set it up and they both come in here, there's a switching time. There's also a sampling time. I'm not going to get into that. For this project, it will never matter. If you want, you can just use this one for everything. Everything. All of it. Because we're going to have the external very large multiplexer. Okay. The M4 controls the ADCs by default. I told you this. What we're going to do is disable it. We got two commands here. This one, sudo udoo M4 control, disable, and also the status. That's how you know if it's disabled. Really good news, guys. You don't have to do this every time you turn it on. You just do it once, reboot the udoo, and it will stay that way. Look, let me show you. I know this is what you're really excited about. Mark, open Python, open PuTTY. Show me how to access the udoo board. I would love to. Here we are. Cool. Of course, we don't have the date. Why would we have the date? God. Gonna bring this up. And unfortunately, I don't think we can. Oh, I don't think I can make this bigger. Shit. Come on, tell me there's more. Select the session, click on load from left side tree. Select it. Change the size of the font. Under when window size is resized. Cool. Cool. As you can tell, I did not practice this part. Thank God for Google. All right. Window. Size of the window. Okay. Change when windows resized. Change the size of the font. Okay. And now. Yes! Whew. That could, oh. All right. Here I am. Cool. We're in. First, sudo udoo M4 control status. It's going to ask for the root password. This is a serious operation. Who's asking? It's false. Mine is already turned off. I turned it off yesterday. You try this on your udoo board, it's going to come up and say, that's true. In that case, what do? You type in sudo udoo M4 control disable. There's no read back. But if you wanted to check to make sure it worked, press up twice. Cool. And it's still false. You would then have to restart your udoo board. I'm not going to do it because it's already been disabled. But the first time you do this, you will have to do it that way. Okay, now our udoo M4 is disabled. Back to where we were. View, present. Didn't think about how many times I'd have to switch here. Okay, we rebooted. All right, accessing the ADC directly. If you're just on the regular udoo file system using bash, you're not in the Python script, you just type in this. what is this mess? What is all of this? This is a file. Remember, cat reads files. Cat, read the file to a terminal or somewhere else. In the udoo, everything appears as a file. It's all the data is stored that way. So if you want to read the direction of a pin, is it an input? Is it an output? I don't know. There's a file for that pin called direction, and you just read the file, and it will say either in or out. If you want to know what is the value of this pin, there's going to be a file. You just have to read it. In this case, in, voltage 0, raw. So these first 4 all go into device 0. Oh, I did this one twice. But you call the system, you say, look in this file and just tell me the number that's in there. And in all these cases, it comes up with a number. These numbers are mostly meaningless because the pin is floating. Everyone knows floating. If the pin is floating, means there's nothing connected to it. It just made up this number. Could be temperature related. Could be just one diode drop. Who knows these things? And then you try it here with device or with voltage, the 4th one, you get this error. No such file or directory. The reason for this is that voltage 4 does not belong to device 0. Voltage 4 is right here. Unfortunately, the naming convention is such that this is called locally 0 and this is 1. Here it doesn't matter. These are the same. 0, 1, 2, 3. Here, it's called 0 and 1. If you want to, you can ignore that completely and never use anything except voltage 0. It's fine. Next. All right. ADC scale. What is a scale? You know from yesterday that when you read the ADC, you get out a number. In this case, the number is limited between 0 and 4095. And you say, I really want to turn this into a voltage. This is the most important thing. I'm going to tell you, you can. By reading this file where everything is stored. Files. There's actually a bunch of little files. So still in device 0, you've got one more file that's just the input or in voltage scale. And this will be the same for all of these because the ADC is right here. And this is where we get the input voltage. So you only have to read this once. You can store that number in your file. And if you're using all of these, you can just multiply them all by the same thing. If you're only using one, you read the scale one time and then read this as many times as you like. And so I try to read this file here with the cat. And what do we get? 0.805664062, which is exactly what I thought we were going to get. Because this is the number of millivolts per LSB. What is it? Excuse me, what is an LSB? LSB stands for least significant bit. This is the voltage, or in this case, millivoltage, which corresponds to a reading of 1. If you read 2, it's going to be twice this number. You read 50, it's going to be 50 times this number. It's a really simple multiplication. If you're using an Arduino with 5 volts, this number is going to be slightly bigger. There's a really, really cool trick. This is just one of my favorite things to do. This is just so cool. You're going to love this. This is really awesome. Normally, this is 3.3 volts. But what you can do, buy yourself a voltage reference. A voltage reference. What does that do? It makes a very precise voltage. I'm going to pick one where the output voltage is 4.096 volts. And now, this number here is 1. How cool is that? Makes the conversions very easy. You might say, I don't think it's really important to just have this voltage reference here. I could have just done the multiplication. That's true. In many applications, it doesn't matter. In some applications, it matters a lot, especially when arithmetic is expensive. All right. Next. Oh, this is really useful for DAC. A DAC is like an ADC, but it's backwards. You got a DAC. You got some digital number comes in. The output is an analog value. So cool. There's none of these on the udoo board, unfortunately. All right. You saw on this screen how we read this values of these inputs. And then you see here we get the scale. And here we're going to do the same thing, but from our Python code. Yes! That's where the real money is. So cool. If you look closely, though, you'll see that something is different. In the bash terminal, we got this character. What the hell is that? That's a backslash. It's just the backwards of a front slash. But we got a backslash here. That's an escape character in bash. Because in bash, this colon is a special device. Not a special device, excuse me, a special character. If you don't have the backslash, it thinks you're trying to actually do an operation instead of just saying the name. In Python, you don't need that escape character. So just be aware that this line is not the same as this line. And now you ask, what is all this crap? Int, open, dot, read, etc. What we're doing here is we're opening a file and then very quickly reading the contents of the file. Normally, you would have to open the file. That's step 1. Then you have to read the file. That's step 2. Then you have to close the file when you're done with it. Python is a little bit smarter than that. If you very quickly open the file and don't save the handle, what is a handle? We'll talk about it. If you open the file and don't save the handle, and then you just read something quickly, Python will close it for you automatically. So cool. Maybe this is very important to you because it reduces the number of lines in your code and you're in a stupid competition. Mostly it's cool because you don't have to remember to close the file. Forgetting to close the file is terrible. And then the same thing for the scale. But here's the thing. In each of these files, it's just written as text. It's not a binary number. If you, well, I'm not going to write it out here, but you read it, it's going to read as a word or as a 4-digit number, and you have to convert it into like an actual number, right? There's a difference between, in binary, we've got 1 byte. It looks like this versus just the number 4 as a character. And so everything is written in this format. You have to convert it. In this case, we know that the raw value is an integer and the scale is going to be a float. You guys know what a float is? Song knows what a float is. Everyone else know what a float is? A float, this is a data type. Normally, you got an integer. Let's say you have a 16-bit integer, 16-bit integer. You've got 15 bits, for the number, 1 bit for the sign. And so you can, with these 15 bits, you can do 0 to 32,768, 767, I guess. And then this lets you multiply basically by 1 and make a negative out of it. There's no fractional parts. The smallest number you can do is a 1. What is a float? A float stands for floating point. With an integer, it's always like this. Always. With a float, what is a float? With a float, you've got, let's say 16-bit float. You could have 11 bits for the number, and then 5 bits for the point. The rate, I don't know what the word for this is, but it's a multiplier. And so with 11 bits, you can make a number between 0, 1,000, no, 2,048. That's the word. And then here, you can multiply this by any number that you can express with 5 bits. But it could also, or rather, it's a shift. So it's not really multiplication. But what you can do then is you can take this 0 to 2,048, you can shift it to the right by 1 bit. If you shift an integer to the right by 1 bit, you get 1,024. Not with a float. With a float, you get 1,024.0. If you started with 2,049 and you shift an integer, you get the same, 1,024. But with a float, 1,024.5. So cool. Why does this matter? This is the number in the file for the scale. If you read it as an integer, it will read 0 and then stop, and all of your data will be useless. You read it as a float, it reads the whole thing. Maybe it won't be super precise. You might lose it. That might become a 3 at the end, but still. You read it as a float. Then you multiply the two together, and the output, unless you say otherwise, is going to be a float. This is a precision issue. You multiply one number that has a decimal to one that doesn't, the output will have a decimal unless you explicitly say you don't. This is going to be not super important in your presentations or in your calculations, but it does bother me at a very deep level when people use floats for things that they don't really need a float for. Do you guys know significant digits? Maybe from chemistry class? Significant digit. What is a significant digit? There's a joke in America. A man works at a museum. He's giving a tour, and he says, these dinosaur bones are 60 million and 5 years old. And the guest at the museum says, that's incredible. How can you know that it's 60 million and 5 years old? And the tour guide says, when I started this job 5 years ago, they told me it was 60 million years old. This is significant digits. If I have $1 million in my bank account and Kelvin has 25 cents in his bank account, how much money do we have together? $1 million. It's about precision. So when you're using a float and you get a number like this, 0.805664062, there is an expectation of precision. There's an accountability. If you ask me how many millivolts is the full scale, I might say it's 3,300 plus or minus 50. I'm not going to commit and say it's 3,312 or 3,301. It might be these things, but I can't guarantee it. And so here, these last 4 digits, maybe the last 5 digits are total crap. If you use them in your calculations, the last 4 digits, 5 digits won't even matter. So you're calculating the concentration of a gas. And you say, oh my goodness, we're at 41.1001273 parts per billion. That's a very precise number. If you report this in anything, on a data sheet, in a presentation, in an advertisement, I expect that you can measure the difference between this and 41.1001274. If you can't promise me that the measurement is accurate to this distinction, don't include it. Probably you won't be able to get past here. If you can get to just 41 parts per billion, that would be so fine. That would just be excellent. So in your reports, your presentations, I don't want to see parts per trillion, parts per quadrillion, number of atoms. That's crap. I will call your bluff. If you tell me it's 3 parts per pentillion, I will ask how you know, because that's very impressive to get with these sensors. Okay, some Python, an interlude, since we're going to have to open and read files. It's really simple in Python. We give it a handle here, and you say this file, or the file handle, equals open dummy.txt. This is a file that I made for the demonstration with this R thing. What is that? This R means you're going to read the file. I expect that for your server work and your app work, you're going to be reading and writing in files. This is a standard. If you don't specify that you want to read or write or append or do both, the default is that you're just going to read. If you say that you're going to write, the expectation is that you will start writing from the beginning. If you want to write to the end, you use A for append, like appendix. It goes at the end. And if you want to do both and surgically splice sections and overwrite them, you need this plus. And I don't think we're going to use that at all in this course. Maybe we will. I'm not planning on it. Maybe you can think of a fun way to incorporate that for your personal projects. Okay, so we open a file with this expression here. But what is actually the file? Because it's not everything in the file. This just becomes a number. The number is a location on the computer where this file is hiding, or where you've stored it. And if you ever say, I want to read from the file, it doesn't know this name. It only knows the location, which is stored here in the file handle. A handle, you know what a handle is? That's how you grab something. I don't have any, oh, here we go. This is a handle. This is a case. If you want the case, you grab the handle. You want to pass the case to someone else, you give them the handle. This is the same with files. So here I've opened a file and I've made a new variable called contents. This is all in Python, by the way. New variable called contents, file dot read. If you don't specify how much to read, it will read the whole thing, all of it. In this course, or in this case, it probably won't matter that much because the files are not super large. They're mostly one word or one number. In this case, the file is just 3 lines Here I've got some new lines here and it doesn't print quite right. But anyway, it reads the whole thing. When I call on it, it just prints the whole thing back to me. Here, you can read them into separate lines. So here I've got the same file, and I'm just going to read these lines out of the file, and instead of storing it as one long string, it has stored it in this array, or a list, technically, where each item in the list is one line from the file. Cool. Maybe you have a file where you keep all of your configuration data. I recommend you do that for this project. You should store the time. You can store any user data if there's a wireless network you're trying to connect to, or another website. Certainly the server where you store all of this data, you can store that information in this file instead of putting it in the code. Then if you want to change the server destination or change something else, you just change that file. You start with file.readlines, and then you just get all of your variables in this nice list. We can go over that some more later. I think this is the last slide about using files in Python. Thank goodness. Writing to a file. I'm going to open this dummy file.txt. Now you saw on the previous page, this file already has crap in it. I'm going to open it anyways with intent to write, and I'm going to write, ah! And now, if I try to read from this file, we get an error that says, you didn't tell me you want to read from this. Shut it down and try again. So I close it. We're going to open this file again, this time to read it. And I'm going to read, and there it says, ah, exactly like I had it before. This is stolen from Keith's presentation. Thank you. If you have a file and you want to read it one line at a time and do something with each file, if it's a very long file and you don't want to read the whole thing first and then massage the data afterwards, you can use this handy setup here for the line. You open this file, this is the handle now, and then for each line in the file, we're going to parse some data, whatever. This will be really useful if you got historical data. You say, I'm going to measure the temperature and the air quality every 20 minutes for the next 50 years and store it in one file on a flash drive. And then after 50 years, you want to get that data out. It's all on these own lines. You can parse it with this. Cool. This will be useful for historical data when you're trying to synchronize with an app. And nominally, every time you take a measurement, there's an Android device nearby, can get that measurement from you and put it on the server. Done. This won't always happen. Maybe 3 days pass, no one asks for the data. And then this Android device shows up and it says, give me everything you got for the last 3 days. You'd be very glad that you stored it in this file. Oh. Okay, so we saw how to do, let me come back here. Here's how we read from Bash. Here's the same thing in Python, but now you know what's going on. We've got the raw voltage, gonna make an integer out of the contents of this file. And you'll notice in this example here, we made a handle for the file, and then we had to read it and do stuff with it, and then close the file manually. In this case, because we're only going to use it once, we don't have to really give it a handle. We can just say, open this, and then immediately read it. This is a method that you can use with a file. Cool. In fact, these are special files. the PC, or not the PC, Linux doesn't really like for you to hold on to them for too long, just for these interface files. For a data file, you can open it, keep it as long as you want. But for these, if you try to open it and keep it open, let's say you want to read the voltage from an ADC, that's fine. But then you don't close the file and you try to read it again. It's going to say, I can't do that. You still have the file open. How can I write into the file when you're writing into the file or reading from the file? So use this method. You just open it, .read immediately, close it immediately, we're done. So cool. This is your bread and butter. My recommendation for you, my strongest advice, is that you make a library or just a definition at the beginning of your code with this in it. Int, open, yada, 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 blah, blah, blah. And then call this analog read 0, something like that. And then when you want to read something, you don't have to type this out every time. Same thing for the scale. Good news about the scale. This does not change. Probably not ever. You might have the option of changing your udoo board analog reference voltage to 1.8. Don't do it. You won't have to do it for this course. There is another pin. Come back up here. A ref, which you can use to supply your own external reference. I erased it, but I had a little drawing of that up here. In this case, stick with 3.3. It's going to be perfect for this project. I say perfect, it'll be fine for this project. Okay, that's how to read these analog pins. If you're curious and you want to see what else you can do with an ADC, or how, if this was not clear enough, click on this link. Oh man, I love the udoo documentation. These guys know everything about the udoo board. Here it is. It's all right here. It's all right here. But you look down here, this is only the bash implementation. You want to do it in Python, it's right here. You want to do it in PHP, go to a different course. And it says here precision, you got 12 bits. We already discussed that yesterday. Cool. Next, the digital pins, your favorite. It's like analog, but easier. It's still going to be controlled by the files. You go into the GPIO folder, these are all the pins that you can access. You can rewrite things so that you can actually access more than this, maybe through different folders. You don't need to. More than enough here for this project. You're really interested in all of the other pins? Go to the udoo documentation. It's all right there. Unlike the analog pins, you can actually change the direction of these. GPIO stands for General Purpose Input and Output. The default when you first turn on the udoo board is that the pin is an input every time. I think that's consistent every time. If you want to make it an output, so easy. Just open this file and write into it the word out. Cool. You want to read a value, the same as with the ADC, but it's a shorter, much shorter file name. And the value is going to be either 0 or 1. The default is an integer. There's actually no way to get a decimal value out of this. That's cool. Here we are in bash again. And then here we are in Python. You can see I'm using nano. Set my direction, or rather I'm reading the direction, and print the direction. I'm going to read the value, print the value. The default is an input. and it actually has a new line at the end of it, that's okay. The default is an input, and the value is 0 because it's floating. It could have been a 1, but most likely is 0. We can connect things to it, like on a breadboard, and get some different values. Yes! That's it. That's everything there is to know about digital. That's not everything. It's everything you're going to need to know about using digital pins on the udoo board, and also analog pins. It's 11:30. I'm gonna say everyone take 5 to 10 minutes to do some hygiene. Go to the restroom, get a drink of water, take the elevator, go get some fresh air. We come back here at 11:40, and you get to watch me, your favorite thing. This is empty. Yes, sir. Question. Okay. Okay. Alright. So let okay. I'm gonna let me here. Go into properties, sharing. Okay. I'm gonna disable this real quick. It's gonna take a minute. And what is this? YOLO. YOLO. Enable this. Oh, good thing. All right. So this, let's try it. Oh, you have a, oh, very cool. And then bring up our key. How about this? What's this number all about? You check this is your user board. We go into details. 1 and 2 and see if we do 7.1. Cool. So we're gonna play it. Thank you. 1, 9, 2, 1, 3, 2. Bam. Let me in. All right. Give me that. Give me that good ping action. Give me that. We're in. It's in the beginning of the presentation. It's because you were sharing with the device, then you unplug the device, it stops sharing. It thinks that you plugged in a new device, and it doesn't, it's not really sure. So you just have to uncheck it, close it, and then reshare it again. That's it. That's it. I did the same thing on my computer this morning. I woke up 5:30. I was so excited to udoo, and it's not big. Now, without the internet, you can still do all of this in Linux. It's just if you want to put your stuff on GitHub, if you want to get the date, things like that, it can be useful. The question? Yes, sir.
I am doing now sensor management.
Okay.
Yeah, but I don't know how communicate between sensor and app.
Sensor and the app. This will be done over Bluetooth.
Bluetooth.
We'll talk about it later. We'll talk about it later. Later. That's another very good news. You just download a library for Bluetooth, and it works with Python, and you don't have to do most of the true Bluetooth is awful. There's so much that you have to set and configure, and it's a nightmare. But just download this library, thank you, Python, very popular. Someone already did this. And then you just import it, and a couple commands, you're done. this is how you will get the data out into the app. But for now, don't worry about it. The greatest thing. Once it crosses into the app, you're done with it. This is my favorite thing, is when you can draw a boundary and say, this is my part. I'm only in here. And someone will say to you, can you help me with the app? And you say, no. I mean, maybe you can say yes, but you're not responsible. If you can't help them, that's okay. But your only responsibility is to get the data onto Bluetooth. And then once they have the data, you're done. And then, question? Yes. Let's. Okay. Okay. Update, bottom. Bottom. You're impressed. My Korean is very good, right? All right. Come on down to, let's see, N should be. Oh, is that network adapter? Yeah, that one. And then just wait. And then just go down to Microsoft. There. And then hold on to ND, promote NDIS. How about NDIS? Yep, NDIS. Is there anything else that starts with NDIS? No. Go up to NDIS. Yeah, just pick that first one there. And then, okay, it's going to say, are you sure? You say, yes, I am. See, my Korean is very inconsistent. I can only navigate network and say my own name. And what is this? What is the problem? Okay, close that. Close this. What is this? Okay. Double click. Can you go to the control panel? This one, and then into the network. Yes. Okay. Okay. So we got two virtual hosts. And I have to disable these in order to use it with. And I'm going to disable this as well. So let's see. That's gonna. I'm gonna unplug this. I've already got this. The one you got from Johan. Yeah. Okay, it's coming up. This the bomb. All right, let's this update driver. Let's try it again. Maybe we got the wrong one. Wait. 컨트롤 X 누르면 이거 이거 치고 해서 나오면 NDI remote sharing device. Which one of these NDIS? Maybe top. It's going to be one of these two. Andy, use the man. Help her out.
인기가 없는 거인 것 같고. 뉴스는 그분이 최고야. 없는 게 없어요. 나이스. 나가면 저거 유튜브 센터도 있어. 뭐가 궁금해요? 좀 친한 방법이 있어요, 그런 거. 우분투. 이거 쓸 거 아니잖아요. 우리는 왜 4개짜리 없다.
그거는 여기 체크돼 있어. 드로 바이 사이즈. 그리고 말고
똑같은 회사에서 나온 4개니까 하나만 플러스 잘 만들면
이게 드라이브. 이게 드라이브. 이거 OX 사이. 사고를 지고 그거를 하고 알파 센서 있고
I have a last question.
Yes.
My team knows about how to register sensor to server.
From sensor to the server,
Yeah.
it has to go through the app.
Yeah.
So the app, I don't know, put it on Wi-Fi? I have no idea. Let John and Mike solve it.
Yeah.
We only work to get it into the app. When the app has this number, the rest we don't do. All right, looking at my udoo board here, we've got, I'm looking at my outer pins, we got, this should be ground, and then the second one here. Oh shit, look at that, 3.341. This is pathetic, udoo. I am disappointed. Okay, think about this. udoo tells me 3,300 millivolts. The true value, 3,341 millivolts. What? So if you go into the file and you get the voltage scale, it's the wrong number. 1% error. What? 1%. How much is 1% in a 12-bit system? 1% error. How much? 5 bits, I think. I think it's 5 bits error.
Yeah.
Yeah, that's serious business. That's okay. We know the right value. My recommendation, put this in a file and say, I know from the udoo board that I've got that this is the real value, not this one.
Isn't it different with our audibles?
Maybe. We'll check it after class. Another thing you can do, you can have, let's see, we have 4 inputs, and you can put all of your equipment for all of your sensors on this one, input 0. Like this. What you can do here is have a reference and say, I know, I'm positive that this is 1.024 volts. Then you measure this one first and then you can define the scale from that. This is how you would calibrate it as you go, or each time you turn it on.
How much is serial pin?
How much what?
Serial pin. Serial port.
Serial port. How much?
How many?
How many serial ports does a udoo board have? More than one. How about udoo neo serial port? I think 3, but let's ask. Let's ask the holy crap.
Wow.
So wait, there are 6 of them. Some of them are already used. For instance, this one, UART3, is always going to the Bluetooth chip. So you can't use it for something else. UART6, this one is for the main processor to use whatever you want. And then this one is for the Arduino to use. If you're not using the Arduino or the M4, then you can have this one back and use it for whatever you want. You might not be able to use it as a serial port, but you can use those pins. And then this one, they just didn't give it to you. Lame. Anyways, hopefully that answers your question. You have a few. This one, the first one, is just for debugging. That one you can't change, but you can use the other ones, or this one, for anything you want. All right. Whoop. God damn it. Worst. Ah, shit. I just did a terrible thing. I just did a terrible thing, which you guys should not do, which is I shorted out 2 pins on the udoo board by touching a piece of metal. Be more careful than I am. Even better, put your udoo board in a box. Yes, thank you. Let's see, back to where we were. Come on. Son of a bitch. Goodbye. Sorry. Good morning, udoo. Okay, so here I'm in my udoo terminal at the home directory. Gonna list some files. Look at that. I already made some files for us. Let's change directory. We're going right into the projects folder. Let's see what's in here. Oh, look, there's two files. One is an ADC test. One is a digital I/O test. Let's have a look and see what's inside ADC test. Thank you, Nano. This looks very familiar. We're going to read a raw voltage. We're going to read a scale. I know that the scale is incorrect, but I'm not going to fix it right here. And then we're just going to print whatever that product is. If I had edited the file, I'm going to do that right now. Mark rules. I'm going to save it. Control O. It's going to say, do you want the same name? Yes, please. And then Control X to exit. Now, oh wait, let me just check, make sure that's reading the right. Okay, we're reading voltage 0. Cool. So now I'm going to run a Python here. ADC test.py. Give me a number. The number is 875, more or less. Mark rules. What is this 875? You may be wondering, what is this circuit all about, Mark? Let me show you. This is a very sophisticated circuit I've just made. We've got 3.3 volts here coming from the board. I have 4 resistors to ground, also coming from the board. This one has a value of 1,000. This one has a value of 1,000. This one has a value, it's the same, and also this one. And I'm reading this voltage right here goes into A0 on the udoo board. And it's reading nominally, we would hope, 33, or should say, sorry, 30, we'll do it in millivolts, 3,300 millivolts divided by 4. Let's see, half of this, it would be 1,650, about 825 is the answer. And you can see we're not actually at quite the perfect 825. That's weird. Is it because of errors in our resistor values? Maybe these are really cheap parts, and this is 1K plus or minus 10, and this one is 1K plus or minus 50. Who knows these things? Anything could account for this. It could be that the ADC is really crappy. Here's what I'm going to do. I'm going to rerun it and just see what happens. That's not even the same number. Let's run it again. A different number. Oh, that's close to the first one. Oh my goodness, it's a match to this one and this one are the same. Let's do it again. This one and this one are the same. Remember yesterday, oh, that's a new number. Yesterday I said we can cheat because the precision is not very good. We can actually oversample it, add it all up. You can either divide it back and get a very consistent number, or you can keep it all, shift the decimal, and get a more precise number. There's still going to be some error in it though. What I recommend is that when you do your calculations, you always treat this as an integer. The reason for this, oh, lunchtime. The reason for this is that the calibration data from the manufacturer of the air quality sensor, let me borrow this. The calibration on this is only precise to 1 millivolt. So if you try to do a calculation more precise than that, your number is going to be crap anyway. You just can't promise more precision because of the calibration. I'm going to move this now to the middle. Reading off of right here, we would hope to see roughly 1,650 volts. Sorry, millivolts. There. Oh. 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 This is roughly double what we got before, but still not what we expect. There's going to be some offset or maybe a gain error. These are things that we can work around. This is some calibration. It's going to be specific to the udoo board. In general, when you get an ADC packaged with a processor, it's really a processor first, and then they put an ADC in there. If precision matters, get a separate ADC. I'm going to teach you how to work around that by including a voltage reference, taking some basic measurements. So here I'm going to connect to the very top of the tree. This should measure, we would hope, 3,300 volts. Oh, that's very good. You know what? Maybe it was just the resistors were not perfectly calibrated. Let's measure the bottom here. Oh, 0. Excellent. Maybe the ADC is better than I thought, and it's just a component issue. Let's try reading the third here. 2,600. Let's see, 17.4. That's actually pretty close. That's getting better. Anyways, you won't have this problem with your boards because you're not going to use these crappy resistors. Anyway, let's read something else. Digital I/O. Cool. Get over here. Digital I/O test. 0. But I also don't even remember which pin I was. Oh no, it was 25, I think. It is 25. Where is pin 25? Next page. GPIO 25 is down at the bottom there. So here I'm reading the 3/4 value. Save modified buffer. No. Read again. Oh, whoops. Wrong. Huh. It's only reading 1. Or, sorry, it's only reading 0. We expected to read a 1. Let me put it right up at the top there. Let's see what we got. Well, something's wrong with my digital read. That's how it goes. I guess I'll have to figure that out later. Hopefully it's just something wrong with my circuit. Uh, 25, right there. Aha! All right, I solved the issue. I was using this one, GPIO 25. I should have used this name. I didn't realize that it was already doing the conversion. Cool. So now I'm going to go down to the 3/4 voltage. We read it again. Boom. Still works. Now I'm right in the middle. Who knows what it's going to read? It could read, oh, 0. That's not too bad, but it's actually slightly below. And then it's going to be zeros all the way down. For your homework, yes, you're going to use the digital pins to make some LEDs flash. All right. You have to set them to an output mode by writing into the direction file, and then set the level by writing into the value file. I'll send an email to the sensors people with more information. You should all have LEDs and resistors and wires and a breadboard, except for Nia, who is the first person to ever receive a udoo board without all of that other crap. And for you, you can have from my personal collection. I've been hoarding LEDs and resistors all these years, waiting for someone to approach who needed them. You're not going to get my personal air quality sensor because I don't have one. Sorry. That's it. That's what we got for today. I'm gonna stop recording.